Hey there, everyone. Yesterday's lesson was a lesson where you reviewed graphing inequalities in one variable. I'm assuming that that was work that you did in the 7th grade, so I'm hoping you didn't find that too difficult. But today we're going to move it ahead a little bit to graphing two variable inequalities, so situations where there's an x and a y in each. And as you can see by this title page, these topics come from chapter 9 in the CPM book. So I'm taking some examples from 3 different sections. The first one will be graphing a linear two-variable inequality. The second one, I'm going to add a couple of non-linear inequalities, one that's exponential and one that's quadratic. And then from section 9.4.1, what does it look like when you're graphing systems of inequalities? Like, how does that get presented? So that would be a situation where you have 2 inequalities or even more on the same graph. All right. So let's start off with one of the examples from the book. So this is from problem 966, and here's what I want you to do. I want you to take a look at that inequality. So it says y is greater than or equal to negative 2x plus 3. I want you to look at the ordered pairs that are there and see which ones work in that inequality and which ones do not work. Okay, so pause this video, try it, and then when you're ready, get the video going again. All right, so you can see I did a little bit of work here myself. And what I discovered is that the first ordered pair does not work in the inequality, but the other 3 do work in the inequality. And you can take a look at the work that I did here. So let's take a look at the first one. So y is greater than negative 2 times x plus 3. So I ended up with 5 is greater than or equal to, so this would be 6 plus 3 or 9. 5 is greater than or equal to 9. No, that's false. So since it's false, it does not work in the inequality. Let's take a look at this one here, 1, 1. So when I plug that in, I have 1 is greater than or equal to negative 2 times 1 plus 3. So negative 2 plus 3, that would be 1. So yeah, 1 is greater than or equal to 1 because it's got the or equal. This one, where it's the same number, where it's equal, is significant. All right, so it is important, or it shows up in a particular way in the graph of the inequality. So I'm going to come back to this one later. All right, let's take a look at how we actually do the graphing. All right, so what we're going to do now is we're going to take the same problem, problem 966, and we're going to use this one to answer this question. How could you show all of the points that would work in this inequality on a graph? And by graph in this situation, we mean a Cartesian coordinate plane, right? Graphing when it was just one variable was a number line. Graphing when you've got 2 variables is basically this here, okay, the Cartesian coordinate plane. All right, so is there a way that we can actually show all of the points that would work? Yes, obviously there is. All right, so there are 4 steps to this. All right, so I'm going to want you to jot the 4 steps down in your Google Doc to show that you paid attention to the video. So the first step is to graph this as if it is an equation. So I started by graphing y equals negative 2x plus 3. I, of course, did this on Desmos graphing calculator, but if I were doing it by hand, I would look at the y-intercept, 3. Slope is negative 2, so I would go to the right 1, down 2. There's my next point, 1, 1. All right, remember I said that point was going to come up. All right, just remember, quick review, rise over run. So this would be the same as negative 2 over 1. You can see I'm doing that with the arrow. So to the right, 1, and then down 2 since it's a negative. So rise over run. All right, second step in graphing an inequality is to determine whether the line should be solid or dotted. This compares to the boundary point on the number line that you did yesterday. And remember, boundary points can either be closed or open, depending on whether the variable could actually be that value. So for example, if you had x is greater than or equal to 3, that would be closed because x could be 3. But if you just had x is greater than 3, that would be open because the x couldn't be the 3. So the way I always say this is we shade in whatever the point can be. All right, well, same here on the Cartesian coordinate plane. We're going to actually shade in all of the portions on the graph where the x and y values will work in this inequality. All right, so it's very similar to the open and closed boundary point in that if it is something that has an or equal to it, we're going to put that in as a solid line. That tells me that the points on the line work in the inequality. If it's just a greater than or a less than, that's going to be a dotted line. Right, I'm going to do a few examples that will have dotted lines in just a bit, but that would tell me that the points on the line do not work in the equation. Right, so let's take a look then at the next one. All right, so by the way, we know this one should be solid because it has the or equal to. The third step then is to check a point. You can choose any point you want, but as you can see, a lot of people choose 0, 0 just because it's easy to work with. So you check a point and see if it works or does not work on the line. And then that will let you know, or in the inequality, and that will let you know whether or not you should shade that in. All right, so when I have my 0, 0 here, I have 0 is greater than or equal to, this is going to end up being 0 plus 3, or 0 is greater than or equal to 3. No, that's not true. So that means 0, 0 does not work in this inequality. Right, so if I were going to shade some things in, I would make sure that the 0, 0 was not shaded in. Right, so what we do is we actually end up shading in one side of the line. And you can see I'm sort of doing this with my arrow. If I were shading this in with a pencil, I would shade in this side, the side that does not have 0, 0 on it. All right, let's see what Desmos does. All right, sure enough, you shade in the correct part. Desmos has this part shaded in. All right, let's try another one. Oh, by the way, what this means is any point inside this shaded area, which by the way would go, out to infinity, any point in this shaded area, including on the line, will work in the inequality. All right, so let's take a look. This is problem 968. Let's take a look at this one. So this is y is greater than negative 1/3 x minus 1. First step, graph the line. So I've got my y-intercept. This time I'm going to go over to the right 3 and down 1 because my slope is negative 1/3. Second step, determine if it is solid or dotted. Well, in this case, it's a dotted line. Now, if you're working in Desmos and you need a dotted line, to the left of the equation or inequality, there's a little circle. It's a colored circle, and if your mouse hovers over that or you hover the mouse over that, it will give you several options, including different colors and some dotted lines or even lines made of little circles. All right, so this one should be dotted because it's just greater than. Next, we're going to choose the 0, 0. See if it works. In this case, I plugged the 0 in and ended up with 0 is greater than negative 1. Yes, that's true. So that tells me 0, 0 should be shaded in. And sure enough, Desmos has it shaded in. All right. So in Desmos, I just put this right in here. If you have a greater than or equal to, you might need to use the calculator in Desmos to get that figure in there. All right, let's take a look at one that is nonlinear. So this comes from the next section in the book. And here's the equation that they want you to start with. Really, this is an inequality. I changed it to an equation over here. I want you to note that the y-intercept is 4, or the multiplier. Well, think about that for just a second. Remember, the y-intercept happens when x equals 0. When this is 0, this is going to be 1. So it's just 4 times 1. All right, so I hope that made sense. This is an exponential equation. You can see as the x values are going up, the y values are going to rise very rapidly. So that's one indication it's exponential. Plus, you can look at the form here. If the variable is the exponent, that's an exponential equation. This one, of course, inequality. This one, the equation. All right, second step, same. So by the way, the steps for graphing the nonlinear inequalities are the same. Okay, so second step, dotted or solid? Dotted. Next step, again, try 0, 0. All right, so I plug the 0 in here. Oh yeah, that gives me the y-intercept. Right, is 0 less than 4? Sure is. So 0, 0 should be shaded in. Let's see what Desmos did. Sure enough, shaded it in. So it's the same steps. It's just that this one's nonlinear. Right, this example is quadratic. And remember, when the variable is a base, basically what you would call the base number or base, that's going to be a quadratic. All right, so in this case, again, same steps. I'm starting by graphing, and you can see this makes an upward facing parabola. Next step, solid or dotted. Well, I bet you can tell just by looking at it, this should be solid. All right, next step, try the 0, 0. All right, so in this case, I think you can see really clearly why using 0 is such a good idea, right? Because it actually will cancel out these first two terms. Sweet, leaving me with 0 is greater than or equal to negative 15. Yes, that is true. All right, so here's your negative 15 way down here near the vertex. All right, so when I put this in Desmos, it should graph in the middle, and it sure enough does. All right, that's everything from the second portion. All right, the third section has to do with graphing systems of inequalities. All right, so graphing systems is just graphing more than one inequality on the same graph. So you can see the directions are graph both inequalities on the same graph and determine where they overlap. I think about this sort of as a Venn diagram. All right, so for example, if you were recording the types of pets that people have, dogs and cats are very common. So let's say you were doing that for like a particular class. Some students would have dogs, some students would have cats, but some would have both dogs and cats. So in that case, they would be in the overlapping part of the circles. Same when you're graphing systems of inequalities. So you can see over here on Desmos, I graphed this inequality. Y is less than or equal to x squared plus x minus 6. So here's that. That's the quadratic. That's the upward facing parabola. And it's a pinkish sort of line. So the inequality part is on the outside of that because 0, 0 does not work in there. All right, so the outside of this parabola goes with this. This is actually a linear inequality. Y is greater than 2/3 x. So you can see here's the y-intercept. You go to the right 2, to the right 3 up 2. So here's your next point, dotted line. Right, and it's going to be above that line, right? So there's that, so that's purple. Right, now in terms of systems, the areas that overlap would be, in this particular case, sort of like the pinkish purplish part. If you were doing this by hand, you would only shade this part in and this part in. So you can see the ordered pairs that work in both of these inequalities are actually not in the same part of the graph. So that's kind of a cool thing. All right, so there's that one. Let's take a look at one last one. So in this situation, I have graphed both of these inequalities. I decided to do one that was an absolute value function. So y is greater than the absolute value of 2x minus 1. And remember, with the absolute value functions, they show up as like the letter V. It's kind of like a cone shape. All right, so this blue portion, not on the actual lines in themselves, but because it's dotted, but this blue portion is what works in this equation. And this orangey portion is what works in this downward opening parabola, which is y is less than or equal to negative x squared plus 10. Remember that little pattern, the negative x squared, that is an indication that it's going to go downward. All right, but you can see it's just this portion in here where basically the points will work in both equations, and that's actually a very small area. So not very many points are going to work in both. All right, you guys, that's it. I want you just to fill out the questions in the Google form, get it handed in, and nice job on this, everyone.